Do you like stepping out of your comfort zone? Did you know that you can leave it not only by changing your job or place of residence? The fact is that after the James Webb Telescope entered the cosmic stage, orthodox astrophysics has come closer than ever to a grand failure. This state-of-the-art optical device has an amazing superpower. It can peer so deeply into the universe that no telescope ever built before has reached such distances. So, what did James Webb see at a distance of almost 14 billion light years? That is, at the very origins of the macrocosm? Its first discoveries have already shown that the familiar information about the possible origins of our world is nothing but a colossus on clay feet, which is about to collapse. But that's not scary. Who knows? Maybe a new, more plausible theory will emerge from its ruins.
Hubble.
So, in schools and universities, we are always introduced to the commonly accepted theories that supposedly explain the origin of humanity or the universe as a whole. This is not surprising, since this question will never lose its relevance. Just remember the clever theory of Charles Darwin. It is said that at the end of his life, like Gogol, he intended to destroy all his works, and above all, his grand work, The Origin of Species, considering it absurd. Although some consider this story to be an urban legend, be that as it may, the catastrophic lack of evidence has not stopped ministries of all kinds from still including Darwinism in school and university curricula. Right now, pretty much the same thing is happening with the Big Bang Theory. It's simply falling apart at the seams. And the reason for this is the James Webb Telescope. What is this already legendary telescope? James Webb is not just some Galileo's tube, but a massive orbital infrared observatory. Its mirror alone is 6.5 meters in diameter. This colossal device was created to search for exoplanets and protoplanetary disks, to study the water worlds of the solar system and its small bodies in more detail, and also to look as far back into the past as possible and finally understand the reason for the existence of everything. And James Webb is doing an excellent job. Since the summer of 2022, it has been sending back quite clear photographs of potentially habitable planets with water and carbon dioxide in their atmospheres, images of gas giants, and nebulae where protostars are forming. But the most important discovery made by this amazing telescope concerns galaxies, and it has already laid the foundation for a future cosmological revolution. What do we actually know about galaxies? They come in the form of ellipses, spirals. Some of them look like lenses or have a bar. Some galaxies are much smaller compared to others. They're called dwarf galaxies. And there are also types of objects that don't fit into any classification. In short, it's a very diverse family. We live in one of these galaxies called the Milky Way. Galaxies play a significant role in the Big Bang Theory. It is believed that they appeared no earlier than 5 billion years after the mysterious detonation of the singularity point. But James Webb made scientists doubt this. What is the Big Bang Theory if we put it in simple terms? About a century ago, astronomers discovered that stars seemed to be moving away from us in different directions, which led them to conclude that something must have given a significant push to this process. Gradually, scientists using indirect calculations came to the idea that about 14 billion years ago, a monstrous explosion was born from an infinitely small and hot point of singularity. As a result, matter began to expand uncontrollably, and the first stars appeared, mainly consisting of hydrogen and helium. After thousands of years, they gradually exploded, filling space with heavy metals produced through nuclear fusion, from which in turn new generations of stars were formed. Then the stars merged into galaxies, and all of this was accompanied by the ongoing expansion of space. Later, this long scenario was called the Big Bang Theory. But is it true? Everything in the universe has its own evolution. We mentioned the evolution of stars above, but galaxies also have their own regular stages of development. If we believe the Big Bang theorists, galaxies simply couldn't have formed in the first billions of years after our universe appeared, let alone conglomerates of several formations. In addition, the stars of early galaxies could contain nothing but hydrogen, helium, lithium, and possibly beryllium. According to scientists' estimates, these elements appeared during the Big Bang literally out of nothing. But James Webb completely shattered these theories. He managed to reach the origins of the universe's formation and saw something completely different from what was expected. At a distance of more than 13 billion light years, scientists saw fully mature galaxies with high metallicity and a huge number of stars. It simply couldn't be, but you can't argue with photographic evidence. What does that mean? In short, either the universe is much older and the process of forming metal-rich stars and their clusters happened much earlier, or the Big Bang theory simply doesn't hold up to scrutiny. And all this time we believed in a soap bubble. So we'll have to look even further to check if these statements are true and finally find the pioneer galaxies, whether they're spherical or elliptical. Basically, James Webb is currently successfully combining the functions of a telescope and a time machine, something that science fiction writers have dreamed about for so long. Its gaze goes deeper and deeper into the depths of the universe in search of cosmological truth, finding objects that have long ceased to exist. But what is it destined to find in this darkness, older than the oldest things? It's obvious that space holds many mysteries that don't fit most of our ideas. Few people know what astronauts keep silent about, those who have been, for example, on the International Space Station, or those who have landed on the moon. Perhaps they saw something after which it was considered reasonable to close the lunar mission for an indefinite period. And right now, we're not talking about the Solaris effect with its vivid hallucinations, where supposedly the universe itself communicates with a person, but about other, more real events. Let's not voice unverified theories. We'll just mention that some astronauts, after many years, still reveal bits of classified information. For example, in 1977, George Leonard wrote a book in which he included National Aeronautics and Space Administration photographs showing strange objects located on the surface of the moon. The author claimed that the photographs were genuine and were deliberately being hidden from the public by the American government. What were these objects? The ruins of some ancient structures, possibly built by a long-lost civilization. It was only in 1996 that National Aeronautics and Space Administration representatives held a press conference on this topic, where they had to give lengthy explanations in order to avoid a scandal. However, let's get back to the ancient galaxies and the strange discoveries of James Webb. Evolutionary astronomers are simply shocked by what the telescope has sent back. According to orthodox theory, it's simply impossible for the first galaxies to be filled with such a huge number of stars, and even with the entire periodic table in their composition. It's similar to what happened with the paleontological record meant to support Darwin's theory. During excavations, archaeologists consistently found the bones of already fully formed animals and birds. But where are the missing links and transitional forms, unlike any particular creature, that would clearly demonstrate the process of evolution? There are very few of them, but that doesn't bother scientists at all. If we extrapolate this situation to the field of cosmology, we see the same thing with galaxies. The stages of stellar and galactic evolution have not been canceled, so astronomers are now in complete confusion. Many of them are unsure and wonder, did they do anything right at all? Or is everything that was considered true just a fiction? It would seem that it's time to convene a world conference and overthrow the Big Bang model as a theory that has not stood up to criticism. But no one is going to do that. Why? The Big Bang theory is the foundation, and if you destroy it, the huge structure that has been built over the years on familiar ideas will collapse. That's why scientists around the world have decided to take a different approach. They plan to reconsider the algorithms of star formation and the evolutionary processes that give rise to galaxies. In other words, it's easier for them to give up a part than to give up the whole. Of course, after such obvious evidence provided by James Webb, creationists became more active, immediately replacing the evolutionists and pushing them off the stage. Followers of this religious philosophical doctrine firmly believed the universe and all within it arose through self-creation. Simply put, it was made by a super intelligent being, known by different names. But what are the pillars that support the idea of the Big Bangs? First of all, the singularity point is always mentioned, about which even quantum physicists have only a vague idea. How, for heaven's sake, can you imagine, let alone describe, an object of infinite density and temperature? On the one hand, it all seems logical. An explosion must have an epicenter. However, notice one thing. If you observe galaxies from the Earth's surface or from our planet's orbit, these objects are moving away from Earth in all directions. So, does that mean our planet is the center of the universe, the place where that very point of singularity was located? But that's absurd. If you, as an observer, arrived on any other planet, you would see the same picture. Galaxies would similarly be moving away from you in different directions. What does this mean in practice? Most likely, if the Big Bang did exist, it didn't happen at some specific point. Space itself expanded, literally every pixel of it. For example, Professor of Astrophysics from the University of Oslo, Ara Raklev, believes that the region where the expansion began is called a point only conditionally, for better understanding. So you shouldn't take this literally. What other prerequisites are necessary for the Big Bang Theory to exist in a viable state? It's a mere trifle, just two hypothetical things: dark energy and a particle called the inflaton. Both components are also in the realm of theory and semi-scientific speculation. According to the proponents of the Big Bang Theory, it was the inflaton that was responsible for the rapid expansion of the universe, just microseconds after the epochal event. Some astrophysicists believe that the inflaton is none other than the legendary Higgs boson, or as it's commonly known, the God particle, which was searched for over many years at Conseil Européen pour la Recherche Nucléaire, one of the largest high-energy physics laboratories engaged in nuclear research. As for dark energy, this hypothetical substance was specifically introduced into the mathematical formula to explain the accelerated expansion of the universe. So what in this theory is real and genuine? To sum up, the explosion wasn't really an explosion as such. Accordingly, this phenomenon didn't have an epicenter, especially not one concentrated at a specific point. Actually, the very beginning of the Big Bang Theory is its weakest point. Among other things, the inflaton and dark energy are literally two dark horses, artificially introduced in attempts to create a coherent theory. However, scientists don't pay attention to this, considering such points insignificant, since everything else basically fits into the developed framework. And then James Webb appeared and destroyed it completely. It's only a matter of time. The universe is diverse. Yes, the part of the universe where we are may be one way, and another part far from us may be completely different. We can't say for sure why it is this way. The important question here is whether the universe has any kind of end. However, we know for sure that the visible universe is far from everything. There is something we cannot see. And the part of the universe that is beyond our sight may be significantly different from the part we can see. But there is also an opposing opinion on this matter. Beyond the visible part of the universe, the properties are the same as in the visible universe. As you understand, we cannot confirm or refute any of these versions. The visible universe is significantly influenced by the rest, and we can observe the consequences of this and make some assumptions based on them. In recent decades, scientists have actively discussed the possibility of the so-called dark flow. But this topic often becomes the subject of heated debates among scientists worldwide. What is this dark flow? What role does it play in the universe? What is strange about this phenomenon? Let's start our story with the cosmological principle. According to it, No matter where we are, at a certain point in time, we will see the same picture of the universe. However, this certainly raises some contradictions for us because, in fact, if we look at images of the universe, it is quite different in many ways. And the whole point is that homogeneity is characteristic of the universe on a larger scale. The universe is also isotropic. There is no direction in it that looks, let's say, somehow special. All directions look the same. The existence of the dark flow, which we mentioned at the beginning of the video, suggests that all objects in the universe are moving in one direction. But according to the cosmological principle, if objects are not somehow connected to the expansion of the universe, then their movements are not coordinated. There is no single direction. Do you see now why the dark flow causes so much debate in the scientific community? There are two options here. Either the dark flow doesn't actually exist or it does, and we will have to reconsider the fundamental principles of the universe. It's worth noting that not all components of the universe move without any pattern. Movement in the universe is constant, even when it's not noticeable, or an object may be static on one level but moving on another. For example, we can sit calmly on the couch in our house, but our planet is moving along its orbit around the sun, which means we are moving as well. What are the peculiarities of the movement of galaxies that are beyond the observable universe? Here we should recall the Hubble constant. The distance to an object beyond the observable universe depends on the rate of its expansion. Let's not forget about peculiar velocity either. This is the speed of an object relative to a state of rest. In such systems, the average value of velocity is usually 0. The movement of such galaxies does not occur in the way we usually perceive movement. Expansion happens, but the objects themselves do not change their coordinates. The greater the distance from us to a galaxy, the faster it is receding. Certain transformations also occur within galaxy clusters. For example, some galaxies exert gravitational influence on others within the cluster. This determines the peculiar velocity of galaxies and how their movement will occur. Peculiar velocity allows us to determine how much the movement of galaxies deviates from the Hubble flow, meaning the motion that depends on the expansion of the universe. Thus, the sum of the peculiar velocity and the velocity that comes from the Hubble constant can be called the total velocity of an object in the universe. There are certain nuances in calculating peculiar velocity. If galaxy clusters are far enough from us, we don't see the full picture. We can only calculate the speed at which a galaxy is moving away from or toward us. The closer a galaxy is to us, the greater the influence of peculiar velocity on the total velocity, and vice versa. The dark flow, which we talked about at the beginning of the video, was discovered, so to speak, because it's not exact in the process of calculating the peculiar velocity for galaxies. The dark flow was first discussed by the Latvian astronomer Alexander Kashlinsky. He and his colleagues wrote a scientific paper on this topic. At that time, in order to determine the peculiar velocity of galaxy clusters in relation to the cosmic microwave background, the scientists used the so-called Sunyaev-Zeldovich effect. The essence of it is that under the influence of the inverse Compton effect, the intensity changes in different parts of the cosmic microwave background. The cosmic microwave background acts as a kind of limiter for electromagnetic radiation. So, in fact, we can't actually see what's beyond this boundary. As you understand, the cosmic microwave background is very important for space science. Over the lifetime of the universe, it has undergone some changes. Now it's microwave radiation because the waves have stretched, but originally the cosmic background radiation was visible light. The distribution of the cosmic background radiation throughout the universe can actually be considered uniform because its photons appeared at a time when there were not only no galaxies in the universe, but no stars either. Nevertheless, in some regions of the universe, you can notice deviations in the distribution of the radiation that originated in the early universe, but they are insignificant. Such uneven distribution contributed to the formation of various structures like galaxy clusters. As a result of long observations, we found out that in some regions of the universe, there are distortions in the relic radiation. You can also notice a trend. The distortions are located in the places where galaxy clusters are found. This is a manifestation of the Sunyaev-Zeldovich effect. There are different manifestations of this effect. We should pay attention to the kinematic Sunyaev-Zeldovich effect. The movement of galaxy clusters affects the intensity of the relic radiation. If we measure the kinematic effect, it can help us determine the speed at which distant galaxy clusters are moving away from us. Let's go back to the work of Alexander Kashlinsky. In 2008, a study was published in which Kashlinsky's team tracked the microwave background using National Aeronautics and Space Administration's Wilkinson Microwave Anisotropy Probe spacecraft, which was created to study the relic radiation. Data from 700 galaxy clusters were used for the observations. This number of objects was chosen for a reason. This way, a more accurate value of the kinematic Sunyaev-Zeldovich effect can be obtained. With this indicator, it's possible to determine the velocity of galaxy clusters relative to the relic radiation and what the deviation of motion is in the expansion of the universe. And so during the research, Kashlinsky was able to determine the kinematic effect. However, the interesting point was that the movement of galaxy clusters was not random, but had a certain tendency. The galaxy clusters were moving toward the region between the constellations Centaurus and Vela. This very phenomenon was named the dark flow. The spread of the dark flow may completely cover the observable universe, and in this scenario, the location of the center of attraction must be beyond the observable part. We can't say how this could have happened. There are forces of attraction acting outside the observable universe, and this gives us reason to believe that it's not empty out there, that there is something there. If the dark flow really exists, then we could study those periods in the universe's existence when light hadn't spread so much yet. That is, those periods that are impossible to study with our current capabilities. But what if all these studies don't reflect the real state of things? Kashlinsky and his team released another study in 2010 to confirm their previous work. For more accurate results, a larger sample of galaxy clusters and a longer observation time were used. In addition, the scientists decided to determine whether the direction in which the galaxy clusters move changes depending on the distance. To do this, the galaxies were divided into several groups, but the authors of the study also concluded that the dark flow exists, that they were right. However, not everyone agreed with these conclusions. Other scientists also conducted a study and concluded that there is no dark flow, since they did not observe any organized movement of galaxy clusters in one direction. By the way, there were several studies with similar conclusions. The Planck Observatory was even involved in this, which has more detailed data on the distribution of the microwave background. But this did not help confirm the existence of the dark flow. The scientific community did not reach a consensus. There were discussions, and even Kashlinsky himself and his colleagues published another study where they increased the observation time again and relied on data from Planck and Wilkinson Microwave Anisotropy Probe. And yes, they once again concluded that the dark flow exists. Yes, the situation turned out to be ambiguous, but that's completely normal for science. Even though the discussions about the dark flow haven't died down yet, in time we will discover the truth. It would seem that 54 years have already passed, but the legendary mission of Neil Armstrong, Edwin Aldrin, and Michael Collins is still well known. And, as you understand, that flight was a very, very long time ago. During this time, space science has advanced tremendously. modern technologies truly work wonders, especially in the field of exploring the vastness of the universe. However, just think about it. The last manned mission to land on the moon was in 1972. So why aren't there any flights to Earth's satellite now? What is the main reason behind this? Surely the first things that came to your mind were various conspiracy theories like the moon landing was actually filmed in a movie studio, that it's the biggest hoax in history, and so on. In this video, we won't be discussing them, but we will say that they all come down to one question. If moon landings were successfully carried out before, then why can't it be done now in the age of modern technology? Unfortunately, it's not possible to answer this question briefly. The situation is far from as straightforward as it might seem to fans of conspiracy theories. First, we need to understand the historical context in which the idea of landing a human on the moon originated, and how this plan was later carried out. As you remember, it was the height of the Cold War, which in the 1960s took the form of a space race between the United States of America and the Union of Soviet Socialist Republics. It was the latter that managed to pull ahead first. The Soviet Union created the first artificial satellite to reach orbit, and then sent the first human into space, Yuri Gagarin. Assessing the situation, CICI realized they needed to do something bigger to get ahead. They decided to land a man on the moon. As you can understand, CICI were driven primarily not by research motives, but purely political ones. And so the astronauts landing on the moon took place. Points were scored in this race, and accordingly, interest in all of this gradually began to decline. National Aeronautics and Space Administration felt this very strongly. Their budget was significantly reduced. Because of this, future Apollo missions were put at risk. Each such mission required a budget of over $1 billion. As a result, the number of missions began to decrease, since in fact, no one was really interested in them. A significant role here was played by the lack of motivation to be first, to outplay some other country, since by the 21st century, CICI practically had no strong competitors left in the space industry. That's how it turned out that further manned landings on the moon lost any real meaning. As sad as that may sound, it's still financially tough for National Aeronautics and Space Administration to manage something like that. Usually, developing a single launch vehicle can cost, let's say, $50 to $60 billion, while in 2022, National Aeronautics and Space Administration's budget was $24 billion. And as you can understand, that's not very much in comparison. Here's another question. There's a lunar module, there's a rocket. So why can't they organize a landing with all this? In fact, there's no need to invest in creating these vehicles from scratch. The thing is, both the lunar module and the rocket were developed in the 1960s for the Apollo mission. Many years have passed and these technologies are no longer relevant. The technological process that allowed these objects to be maintained has changed significantly over this time. Accordingly, ensuring safety is problematic, and nowadays there aren't as many specialists who could work with programs from the 60s. Currently, designing the model and rockets using modern technologies is the most optimal option and requires a relatively smaller budget. The moon now plays a slightly different role than it did in the 60s. Back then, it was seen as one of the tools for achieving political goals. Now, however, it is a key focus of scientific research. A huge number of missions are being organized to the moon. For example, the Chinese automated interplanetary station Chang'e 5 collected samples of lunar soil in 2020. And there is also very good news for us. National Aeronautics and Space Administration is planning to land a team of astronauts on the moon by the end of this decade, which will include the first woman. This is Christina Koch, and she holds the record for the longest spaceflight among women. 328 days, 13 hours, and 58 minutes. In April 2023, National Aeronautics and Space Administration introduced her as one of the crew members for the Artemis mission. Koch will serve as a mission specialist. As part of the Artemis 2 mission, a flyby around the moon is planned, while the goal of Artemis 2I will be a direct landing on Earth's satellite. After that, National Aeronautics and Space Administration plans to implement even more ambitious plans to create a kind of research station where people can stay for an extended period of time to conduct various tests, experiments, and so on. It's worth noting that they wanted to send astronauts to the surface of the moon as early as 2024, but in 2021, after serious discussions, they decided to postpone such a large-scale mission. The pace of preparation did not match the established deadlines. As a result, we got a new date, 2028. They also received White House instructions to speed up the process. In recent years, Americans have begun to show increased interest in the moon, and in general, a desire to revive the spirit of those times when people watched the landing of the first crew on the moon with bated breath. Let's get back to Artemis 3. As part of the mission, it is planned to land a spacecraft with astronauts in the area of the lunar South Pole. The astronauts will have to make 4 excursions directly onto the surface of Earth's satellite. The main goal is to study the terrain, run experiments, and collect water ice samples, which is a challenging task. Before starting such a critical mission, it was necessary to conduct 2 training flights to ensure that everything would go smoothly during the actual flight. In 2022, the first test flight took place, and the second one is scheduled for 2024. If the first flight was conducted without astronauts, then in a year, they will be on board. The progress in preparing for the mission is positive right now, since National Aeronautics and Space Administration is working at an accelerated pace. The Artemis mission's descent module needs to be fully built 2 years faster than it usually takes to create similar modules for other missions. The design of such an object is even more complex, since it is required to successfully transport astronauts to the moon. Obstacles for Artemis have included insufficient funding in some areas, and the coronavirus. How quickly preparations for the mission will be completed depends not only on the work done directly on it, but also on how successful other national aeronautics and space administration projects related to lunar exploration are, such as orbital stations. Some projects, such as the development of the launch vehicle for the Orion spacecraft, are experiencing delays. Yes, for now we're still waiting for what is, without exaggeration, a historic event. We hope that in a few years we will be following the progress of the mission with bated breath, with pleasant excitement, just as people did in the 1960s. And what do you think? How soon will astronauts land on the moon, and where will we be able to watch the live broadcast?